Heidi ho, welcome again. 8.3 day 1, we're going to talk about adding and subtracting these Teenage Mutant Ninja fractions, rational expressions, okay? If you recall, adding and subtracting regular fractions, you need to make sure to have a common denominator. Good. So what we're going to do is we're going to start off with common denominators, and then we'll work a little bit with, unlike denominators, with monomials today. So we break this unit into 2 days, okay? So today we'll start mostly with common denominators. So do you remember the regular process for adding fractions? There's one thing that you got to be careful not to do, and that's what? Yeah, don't add the bottom ones, okay? Do not add the bottom ones. So when you add fractions, if we have 3/4 plus 3/4, that's how many total fourths? 6, okay? And then, of course, that can reduce to 3/2. If you have 5/8 minus 1/8, you have common denominator. So that's a total of 5 minus 1 is 4/8, which is the same as 1/2, right? So just a little brief reminder on how fractions work when you're adding and subtracting. Now we're going to look at some rational expressions. These just have monomial numerators and denominators, but they have common monomial denominator 2n. So we can go ahead and add the numerator stuff and keep the denominator stuff the same. So what do you get when you add n plus 3n? 4n. And then, of course, the last unit that we did was all simplifying these things and multiplying and dividing. So can we simplify 4n over 2n? That would be they're both divisible by 2n, right? So they have a common factor of 2n that you can factor out. So this would really just equal 2 over 1 or 2. Yeah, because it would be like this. Watch. If I rewrote this, I could rewrite this as 2n times 2, right, over 2n. See that? And then I could really, what's really happening here is this is the same as 2n over 2n times 2 over 1, and 2n over 2n is just 1, and 1 times anything is the anything. So down here we have a common denominator of x to the fourth. 2x plus 4x is 6x. So 6x over x to the fourth, those each have a common factor of x in the numerator. So if I don't know, this is kind of unnecessary, but this is also another way of looking at it. X times 6 over x times x cubed. Get your little math machete out. Chop, chop. Chop those two off. They're just equal to 1. So you're left with 6 over x cubed. Oh, by the way, I haven't talked about any restricted values in the variable, but in this case, x could not equal 0, right? So whatever makes a variable denominator 0 is a restriction. So you got to be careful if you're solving an equation and all of a sudden that makes a denominator 0. It's a bogus extraneous answer. All right, are we good? Moving forward. Okay, ooh, now we have binomials. Ooh, scary. But they're common binomials, so it's not too scary. So we have a common denominator, m plus 4. And, you know, sometimes it helps to think of that as like, you know, the whole binomial if you put parentheses around all these things. So you just don't start crossing stuff off. So m squared plus 2m plus 3m plus 4 is a total of m squared plus 5m plus 4. And so now I have a trinomial numerator. So all that stuff is equal to that. Can I factor anything in the numerator? Can I factor that trinomial? Are you a good factorer? Hopefully that's pretty good for you. You can factor m plus 4 and m plus 1. And then you'll see that they both have a common factor of m plus 4 in the numerator and denominator. Get your math machete out. Chop, chop. This is equal to m plus 1. X cannot equal what? -4. -4. Okay, keep on trucking here. Next one. Oh, we got a common denominator. Right. Okay, good. Add those numerators together. This, I can see people adding these numerators and getting like 6y cubed, can't you? Yeah, you can't do that. Be careful. They're not like terms. You can't just add them. So 3y squared plus 3y, that's just 3y squared plus 3y. You have to leave it like that. I can't combine those. They're not like terms. Over y plus 1. Some people probably would benefit from putting parentheses around that stuff so you don't just start crossing stuff off. Okay, now we can factor out a 3y from the top, the numerator. And so we're left with y plus 1. Ho ho! Look at there. This is a happy, fun little math book problem. We get common y plus 1 binomials, and then we can reduce those, and we're left with 3y. Final answer. Oh my gosh. Robot head. Y cannot equal what, Kate? No, because if I put a 0 in there, it'll just be a 1 in the denominator. Try again. What makes it 0? What would make the denominator 0? What would I put in there for y that would make this whole stuff 0? -1, good. So y cannot equal -1. It's kind of like when we solve quadratics, you know, and we want to find the solutions, and you write stuff in factored form, and it's like, okay, the opposite of that. So y cannot be -1. Any questions? Any questions in the way back? All right. Now we have a same concept, more problems. We got a little difference of squares denominator here. So hopefully you pick up on that. And I bet you, because math books and math problem writers are fun people, they like to have action. So I bet you that will factor and cancel out. Add your numerator stuff together, we get 3k minus 18 plus 6 is a total of minus 12. Right? Factor out what you can out of those numerators and denominators. The top numerator I can factor out a 3, and I'm left with k minus 4. And the bottom is a difference of squares, so that's k plus 4 times k minus 4. So I was right, because math teachers just want to have fun. And so those reduce, and we're left with 3 over k plus 4. You know, that would have been a good soundbite for someone who was collecting on all the videos. That little song. But remember, wasn't that your guys' idea? Yeah, that would have been a good one. Maybe for my graduation present. Someday. You can make a video. Kate, let's go back to you. What can k not equal here? There you go. -4. Nailed it. All right. Whoa, trinomial denominator. Whoa. Big time. Off the chain. Okay. Oh, and minus. Oh boy. That's going to be tough, because we can't forget to apply the minus to there and to that term and to that term. You got to distribute it. You got to be careful there. So let's see here. Good thing I have a common denominator already, so that's a little bit helpful. So my numerator, 6y minus 6 minus, I'm going to write this all out just to be sure. Hopefully you get the picture. 6y minus 6 minus, and then you got to put a parentheses around it, y plus 4. All right, I could put parentheses around that if I wanted to as well. I don't know. Sometimes when you do that, people like FOIL stuff, and you shouldn't, because there's a minus. It's not times. But the thing that I want to make sure you realize is this minus is distributed to both of those. So you have to make sure to subtract them both. So it's really minus y, and it's minus 4. So when you put that all together, you get 6y. Sorry. let's not write everything out. 6y minus y, which is 5y, minus 10 over whatever we had down there, which I bet you that stuff factors because math teachers just want to have fun. That might have been a better take. I might have really hit the note on that one. Factor out of 5 there. Factor root of 5 there. And then the denominator, you get what? Y plus 6, y minus 2. Ho ho, y minus 2's cancel. Get your math machete ready. Sudoku. 5 over y plus 6. Hey, here's a question for you. All right, go ahead, shoot. When we do the restricted values for y, can y be 2? Is it restricted? Because I crossed it off, right? So is it still restricted, or is it okay for y to be 2 now? It still is restricted, yeah. Even though it's canceled off, it's still kind of there, right? It's just that you could reduce it. So it can't be -6 or 2. So that's a little tricky. All right, let's see what we have here. Now we have, now we're talking about a little unlike denominators. So remember, thinking least common multiple to get common denominators. So 1/4 plus 2/3. Common denominator or least common multiple between 4 and 3 is probably 12, right? Okay, so in this case, I have to multiply this one by 3 over 3, and I have to multiply 2/3 by 4 over 4, so that I can get both of these as fractions as 12ths. So 1/4 is 3/12 and 2/3 is 8/12. Add those two together and you get 11/12. So you have to be able to get common denominators if you don't have them. So number 9, we have a monomial with a variable in it, 9x and 5x. So if you're trying to get common denominators with variables, look at the coefficients and get the coefficients to match. So least common multiple between 9 and 5 is 45. Okay. And then they both have an x, so we're good. So really it was just 45x. So get both denominators to be 45x. Let's multiply that one by 5 over 5 and this one by 9 over 9. And so we have 35 minus 9 over 5x, which is 26 over 45x. 4 has a funny little hoop-de-hoop on there. I better take care of that. Yeah. Meow, there we go, meow. All right. That would have been a good soundbite, too. Meow, there we go, meow. All right, now we're kind of ramping it up a little bit. These monomials have different variable degree, right? So we got to watch the degree a little bit. Look at the coefficients. 5 and 2, common factor or common multiple, excuse me, between 5 and 2 is 10. So we want to get these to be both coefficients that are 10. And then look at the higher degree. I know there's more than one way to do this, but I'm just going to look at the higher degree and match. So the one with the higher degree is cubic. So then I want to make them both cubics. Okay, so to get the first one to get 5n cubed into 10n cubed, I need to multiply by 2 over 2. And to get 2n squared into 10n cubed, I need to multiply by 5n over 5n. Some clever lad last hour asked, couldn't you just like cancel out n's in the first part to get it to be an n squared? And you could do that on that one, but I didn't see that. And there's more than one way to get things to work out, but you could cancel that out with that out because
you know, they're both monomials, so it's not like you're crossing off a term. They're both factors. But anyway, we'll try to keep it kind of the same process. So try to build up to the higher degree. In this case, we would have then 4n plus 20n squared. Okay, so I'm going to write that as 20n squared plus 4n all over 10n cubed. Factor out what you can, so you can take a 4n out of the top, and you're left with 5n plus 1 over 10n cubed. And now I have a common factor of 2 and an n. So I can divide that by 2n, and I can divide that by 2n, which is essentially like factoring out a 2n. And so I'm left with 2 times 5n plus 1 over 5n squared. Yep. Other people like to look at this and go, okay, divide that by, take a 2n out, so take a 2n out of there. I'm left with 2. Yikes. I'm left with a 2. Take a 2n out of there, and I'm left with a 5n squared. All right, nothing else you can do there, so that's it. Okay, how are we doing? Sleeping yet? You can try these on your own, so I'll pause this. I'll let you guys try it, and then I'll put the answers up so you can pause it, work on them if you want. If you want a little extra practice, a little extra feedback. There's the answer for the first one, 3 over 2x squared. And the second one will be back to you after these messages. And we're back. And I got 37 over 63x. So if I made a mistake on that, I'm sure you'll let me know in the comments if anyone is watching. So other than that, we got a funny joke sheet on this. This is a magic eye, this background. So if you stare at it long enough, you'll see a picture. Just kidding, it's not. All right, that's a wrap.